Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over Arrhenius acids and bases. So let's get into this. So what is Arrhenius acid? I've covered this in another video, but I might as well just review it quickly here. So an Arrhenius acid is anything that produces hydronium ions when you put it in water. And to remind you, a hydronium ion is the H3O plus ion. That's when the water picks up the acidic hydrogen from the acid and you get the H3O plus ion. So the hydronium ion, just to kind of remind you, is the ion that is in solution when an acid is put into water. It's not H plus, so we commonly will write H plus in our equations as a convenient way of representing acid ionization in water. But in reality, H plus does not exist in water. It's H3O plus. That is the H plus that we're referring to. So H3O plus is the hydronium ion. So any substance that when you put it in water produces the hydronium ion is considered an Arrhenius acid, or an acid according to the Arrhenius definition of acids. So then here we have a couple of examples. So if I take HCl gas and I put it into water, the HCl will react with the water. So it will give a hydrogen. This hydrogen is the acidic hydrogen. So just a reminder that in order to identify an acid will always begin with a hydrogen. And that indicates that the first hydrogen in the formula is the acidic hydrogen. That's going to come off. There could be more than one hydrogen, so it could be two hydrogens or three hydrogens. We call those diprotic and triprotic or polyprotic acids. But the point here is that if in order to identify the acid or to identify the substance as an acid, look at the formula. If it begins with a hydrogen, that's definitely an indicator that it's an acid. So here we have HCl, hydrochloric acid. This hydrogen here is the acidic acid. It's going to donate that to water. Water is then going to pick it up and it becomes the hydronium ion H3O plus. And then you have the chloride ion left over, and so that's by itself dissolved in water. So that is an example of how HCl is an acid according to the Arrhenius definition, because when you put it in water, you produce hydronium ions. Also, here we have acetic acid. So again, acetic acid, we know it's an acid because it begins with hydrogen. So this hydrogen is the acidic hydrogen. So acetic acid is going to donate this hydrogen to water, and then water becomes H3O plus, and then whatever's left over is the anion, and then that's the acetate ion here, C3 or C2H3O2 minus. And so this again is an acid according to the Arrhenius definition, because when you put it in water, it produces hydronium ions. Okay, hopefully that's clear. So let's review weak and strong acids. So again, the moniker or the descriptive term strong and weak is referring to whether or not when it ionizes completely in water or does not ionize completely in water. If it ionizes completely in water, it's a strong acid. If it ionizes a little bit, if it doesn't ionize completely in water, it's a weak acid. So that's the distinction. So when we say that HCl is a strong acid, what we really mean is that almost all of it ionizes in water. So very little of this form is going to be in the water, and it's mostly going to be in this form here, hydronium and the chloride ion. So is there going to be a little bit of this in solution? Yes. It's not going to be 100%, but it's going to be pretty darn close. Okay. Weak acids, they ionize only a tiny fraction. tiny, tiny, tiny fraction, barely ionizing. So maybe 0.01% of this is going to ionize. That's a percentage I just came out of my head. I don't know if that's accurate, but the idea here is that only a very tiny fraction of a weak acid is going to ionize. So when you throw this acid in water, like acetic acid, most of it is going to be in this form. Like maybe 99.9% of the acid is going to be in this form, and a tiny fraction is going to ionize to produce these two. And so we call that a weak acid. Okay, so that's a review of the Arrhenius acid. Now let's talk about Arrhenius bases. Very similar to Arrhenius acids in that for the Arrhenius base, it's going to be something that produces, in this case, hydroxide ion, OH minus, when you throw it in water. So here's a couple of examples. So I have sodium hydroxide. Sodium hydroxide, I throw that in water. It's going to dissociate into its ions, sodium ion and hydroxide ion. And so in this case, because it contains the hydroxide ion in the formula, when it dissociates in water, it's producing the hydroxide ion in water. So aqueous hydroxide ion is produced. So therefore, this is a base according to the Arrhenius definition. Also, ammonia here, NH3, is also a base according to the Arrhenius definition for the same reason. So here, if we take NH3 ammonia and we put it in water, the ammonia is going to react with the water by taking a hydrogen away from the water. So it's going to take a hydrogen away from the water. So then NH3 gains hydrogen, becomes NH4 plus aqueous. And then what's left over from the water is OH with a minus charge. That's our hydroxide ion. So ammonia in water will produce the hydroxide ion. And therefore, it is a base according to the Arrhenius definition of bases. Okay, now let's talk about strong and weak. Again, the terms strong and weak are the same when it applies here. Strong means that it dissociates completely in water, and weak means that it hardly dissociates at all. So it's not going to be 100% dissociation. So again, here, when I put this in water, does that mean that all of it is going to dissociate in water? Not all of it, but a very, very large part of it will. Very tiny amount will actually stay together. Weak means that only a tiny fraction will actually react with the water. So when I put ammonia in the water, most of it, a large percentage of the ammonia is going to stay in this form. A very tiny fraction is going to react with the water to form the ammonium ion and hydroxide. But there will be a little bit of that produced. So that, again, is how we distinguish between strong and weak acids and bases. Okay, so now that I've covered that, let me go over a few steps on how you can identify whether something is whether something is an acid or a base by the Arrhenius definition, or when you figure out that it's an acid or a base, whether it's weak or strong. So stay tuned, I will come back. Okay, let's talk about the general steps of identifying something as either an Arrhenius acid or an Arrhenius base, and whether or not that's going to be a strong or weak acid or base. So step one is to identify your substance either as an Arrhenius acid or an Arrhenius base. So here are some things to help you out. One, names of acids end in the word acid, right? So I know that's probably common sense and obvious, but we don't want to ignore the obvious, right? So if you're looking at the name of the substance, if it says acid at the end, then it's an acid. But if you're looking at the formula and you want to identify the formula as a substance that is an acid or a base, If you want to identify it as an acid, um, one, the formulas are going to begin with hydrogen. If it begins with hydrogen, that's a dead giveaway that you've got an acid. And it could come in a couple of different forms. It could come in the form of HX, where X is some sort of anion, right? Usually a halide of some sort, like chlorine or bromine, iodine. Um, so if it comes in some sort of HX form, that would be a binary acid. Example would be HCl, HBr, so on. H2S would be another example. Or it could come in this form here, where you have hydrogen, a certain number of hydrogens with a certain number of some other uh, element plus a certain number of oxygen atoms. And so we call acids that have this form oxyacids for the very obvious reason that they have oxygen in them. The examples of this would be H2SO4, H3PO4, and etc. And one of the things you should notice here is that the oxyacids have the form of having a polyatomic ion with hydrogen added to balance the charge. So that's something to keep in mind as well. So if it has these forms, then you know it's an acid. If it doesn't have that form, then it's not an acid, right? So that's the first thing. So for bases, you're going to identify it as whether it has hydroxide in it. And so I'll write that over. It looks like I forgot to write that down. So how do you identify something as an Arrhenius base? Well, I'll write it over here. So an Arrhenius base is going to have hydroxide in it, for example. So I'll write that over here. So for bases, so identify that has hydroxide in the name or formula. Right. So if you see the word hydroxide in the name, or if you see the OH minus or OH in the formula, that's going to be a dead giveaway that it is an Arrhenius base. There's also other ones that you could see. So if it has carbonate or hydrogen carbonate in name or formula, and that's going to be your CO3 2 minus or your HCO3 minus, these ions. So if you see carbonate or hydrogen carbonate in the formula or in the name, those are going to be bases as well. And then finally, if you see ammonia is going to be a base. So those would be the three that I would look for. So does it have hydroxide in the name or hydroxide in the formula, OH minus? Does it have carbonate or hydrogen carbonate in the name or the formula? If so, then those are considered bases. And ammonia, if you're given ammonia is going to be a base, as we saw earlier. Okay, so identify it first as a base. Oops, I erased my D here. Either identify it as an acid or as a base first. Once you've done that, then determine whether it's a strong or weak acid or base. So, and that's going to be relatively simple because there are only 7 strong acids. So you just need to memorize what the 7 strong acids are. So the strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, chloric acid, and perchloric acid. Those are the 7 strong acids. If it's not one of the 7, then it is a weak acid. Same with the bases. So the strong bases are group 1 metals with hydroxides. So that would be group 1 would be lithium, potassium, sodium, and all that rest, right? So if you have a hydroxide that has a group 1 metal with it, that's going to be a strong base. Other strong bases are going to be calcium hydroxide, strontium hydroxide, and barium hydroxide. These are the strong bases. If it's not one of these, it's going to be a weak base. So that's how you can determine between weak and strong acids and bases. So I hope this was helpful. If you enjoyed this video, if this was helpful in any way, then please by all means like the video, share the video with your friends and family, hit that like button. Also make sure that you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a question or a problem you want me to help you with, please put it down below and I would love to help you with that. Thanks for joining me and have a great day.